Okay, so for our first one up here, P equals V squared over R. We're supposed to evaluate for V equals 12 and R equals 9. So this is going to be 12 goes in for V, so it's going to be 12 squared, and 9 goes in for R. So order of operations tells us we have to do what first here? The exponent. Well, and the fraction bar is telling us we have to do the top first, and on top all we have is the exponent. So that's 144. Nothing more to do on top. Is there anything to do on bottom? No. So that's just 9. Then we divide to get 16. How many had 16? Good deal. So then down here, evaluate the a plus b over 2 times h. For a equals 17, so I put 17 where the a is, plus b equals 31, so I put 31 there, over 2, that's not going to change. Put in my parentheses, and then times h, which I'm going to put in the 12. Here, of course, I have the enclosing symbols, the parentheses. So I have to start in there. Then we have the fraction bar, which is also enclosing symbol, so I have to start on the top of that. So I'm going to have to 17 plus 31, which is 48. Now, I've done everything on top of the fraction bar. Nothing to do on bottom, so I can divide. 48 divided by 2. 24. Now what's in the parentheses is down to a single number, so I can get rid of the parentheses. 24 times 12 is 288. How many had that one? Good deal. Okay, so today we have one more topic left to finish up in Unit 1. And that means tomorrow is our Unit 1 test. For the test, you will be allowed to use your notes and your books and your calculators on the whole thing. We'll take the full hour tomorrow, but you do have unlimited time, so if you need more time than just the full hour tomorrow, let me know, and we'll figure out some way to get you more time to finish it up. That's a very good question. Usually it's right around 30. Let me see if I got it. It's going to be 24 on this one, 25. Okay. So we have one last topic to cover today. And this is a topic that's kind of, it's part of our whole numbers, but it's also going to be vital for our next unit, which is our fractions. And what we're looking at is something called a factor. And a factor is nothing more than a smaller piece or smaller pieces that can be combined to make larger items. So for example, if I put 24 up here, 24 has a lot of factors. A factor of 24 could be 2, because 2 can be used to build 24. Any other numbers that could be factors of 24? 3, 12, 4. Now you say 1. That's a very good thing you brought that up. If I multiply something by 1, does it change? No, it doesn't. So even though any number can be divided by 1, we don't count it as a factor because you really can't use 1 to build anything. Because you can keep multiplying by 1 and it doesn't change it. So we've got 2, 3, 12, 4. There's one more.
8.
Oh, 2 more actually. There's 6 and then 8. Thank you. I almost missed the 8. So those are all factors. Now you might say, well, 24 could divide 24. Again, that kind of goes in the same category as the 1. You can't use itself to build it. So we're not going to use 24 as a factor. Now these are not in order, but that's fine. Those are all numbers that could be used to build a 24. We can multiply them by something to make 24. Or we can look at it as the other way around of we can divide 24 by those numbers without a remainder. If I want to find factors, first thing I need to be able to do is to find numbers that are divisible by others. So let's take a look at divisibility here quick. How can I look at a number and tell whether it's divisible by 2? It's even. Of course, even means the last digit of the number is a 0, 2, 4, 6, or 8. So if I have 74,568, all I care about is that last digit, the 8. How can I tell if something's divisible by 3? This one's a little trickier. Perfect. That's exactly. It's the sum of the digits. So let's look at my 74,568. What's 7 plus 4? 11. 11 plus 5? 16 plus 6? 22 plus 8 is 30. Is 30 divisible by 3? Yes, it is. So that means the 74,568 is also divisible by 3. One of the cool things about this, let's say I'm not sure if 30 is divisible by 3. I can just do 3 plus 0 is 3, and I know 3 is divisible by 3. So therefore 30 is divisible by 3, and the 74,568 is divisible by 3. To tell if something's divisible by 4, it's not really that important, because if something's divisible by 4, I can just divide by 2 twice, and I've divided it by 4. But there is a rule for 4. It involves the last 2 digits of the number. So looking at my 74,568, all I would be concerned with is the 68. Is 68 divisible by 4? Yes, it is, actually. But at the same time, that's not always easy, is it? I mean, I'm guessing you don't have multiples of 4 memorized up to 100. What I do for that is I can divide by 2 relatively quickly. So I mean, 68 is even, so I know I can divide it by 2. 68 divided by 2 is 34. If I can divide it by 2 a second time, then I know it's divisible by 4. So if I'm going to divide by 2 twice, I just will divide by 2 twice and forget about the 4, right? So there is a rule for 4, just not terribly useful. How about 5? How can I tell if something's divisible by 5? Yeah, the last digit is 5 or 0. So 74,568 is definitely not divisible by 5. 827,385. Again, all we care about is that last digit. It's a 0 or a 5. In this case, it's a 5. So we can divide that by 5. 6 is another rule that's not horribly useful, because if you wanted to divide by 6, you could just divide by 2 and by 3, and you'd divide by 6, right? But, in fact, that is the rule for 6. It can be divided by 2 and 3. So let's take a look at 827,385. Can I divide that by 6? If you're adding the digits together right now, you're wasting your time, right? No, you can't, because it's not divisible by 2. It's got an odd digit in the last digit. I always check the 2 first because it's really quick. This one I can rule out right away because 5 is not even, so I can't divide by 2. But let's take a look at maybe 82,000 or 827,380. Let's see, what am I going to put in here? 2. Is that divisible by 2? Yeah. Yes, it's divisible by 2. Is it divisible by 3? Maybe. What's 8 plus 2? 10 plus 7 plus 3? 20. 20 plus 8 is 28, plus 2 is 30. Is 30 divisible by 3? Yes, so it's divisible by 3. No problem. I put you on the spot there. So yes, it's divisible by both 2 and 3, so it's divisible by 6. Now again, that one's not horribly useful because if you got to worry about 2 and 3, just divide by 2 and then divide by 3. It's done. Anybody know the rule for being able to tell something's divisible by 7? I keep asking that question, hoping for an answer, and I don't get one. There is no rule to tell something's divisible by 7. If you guys can one of you guys can come up with a rule that'll tell every time whether a number is divisible by 7, write it up and show it to me, and I'll give you an A in the class.
Even if it doesn't work?
So it has to work every time. It has to work every time. Because I'm going to publish it, get famous, and retire.
I get half the money.
I'll give you a 10th or something like that. I'll give you a cut.
I'd like
Isn't an A in math class enough?
Well, no, because I'm not getting any in the rest of my classes.
Oh, so okay. So 7, there is no rule. We can't tell. 8 is similar to the 4. It's kind of, again, a difficult rule. 8 looks at the last 3 digits. So let's say we have 479,496. To tell if that's divisible by 8, we have to look at the 496. Is 496 divisible by 8?
Yes. Yes,
it is. So that whole thing's divisible by 8. But again, how many of you have the multiples of 8 memorized up to 1,000? Very good. If anybody raised their hands, I was going to worry. Trying to figure out whether that's divisible by 8 is just as much work as just punching the whole thing in your calculator and dividing by 8.
Don't you just look at the last 2?
The last 2 is not adequate because 100 isn't divisible by 8. So up to 100, it would be fine. If this was a 0, all you'd have to worry about is the last 2. But if it gets over that, then you've got to worry about it. If this digit here is even, then you only have to look at the last 2. But now you're getting very complex with the rules. So they just say you got to look at the last 3 digits and if it's divisible by 8. Because if it's 108, 108 is not divisible by 8. 208, 408, 608, 808 are all divisible by 8. But 108, 308, 508, 708, 908 are not. So the odd digits, it doesn't work. So, 9. Anybody know the rule for telling something divisible by 9? Well, you can divide by 3 twice, always helps. And that's what I usually do. I don't worry about 9. But there's a rule, and it's just like 3. It's the sum of the digits again. Only the sum of the digits has to be divisible by 9. So up here, let's take 827,352. Add up those digits. 8 plus 2 is 10, plus 7 is 10 plus 7 is 17. 17 plus 3 is 20. 20 plus 5, 25 plus 2 is 27. Is 27 divisible by 9? Yes, so the whole thing is divisible by 9. And then, of course, to tell something's divisible by 10. Yeah, last digit is 0, right? As long as it's 0, you can look at it very quickly and you can tell it's divisible by 10. Now, there are divisibility rules for numbers going larger, but they get more and more complex. And you only need divisibility rules for certain numbers. Like we talked about how 8 you can just divide by 2 3 times, and 9 you can divide by 3 twice. 12 you can divide by 2s and 3s and you get rid of 12s. 15 you can divide by 3s and 5s. So you only need rules for certain numbers, and we'll talk about what those numbers are called in just a second. There is a rule for 11, but I'm going to draw a line across here because you don't have to write this down, because I'm just showing you just how complex they get as we get larger. The rule for 11, I'm not even going to try to write it out in words, I'm just going to show you an example. So what you do to tell if something's divisible by 11 is you go every other digit. So I go 2, 8, and 5. If I add those up, I get 2 plus 8 is 10, plus 5 is 15. Then you take the remaining digits. 7, 9, and 3 add up to what? 19. The difference between those two numbers, if it is either 0 or divisible by 11, then the whole number is divisible by 11. Well, this is 4, which is not 0, and it's not divisible by 11. So this number is not divisible by 11. But I could do that. 2 plus 8 is 10, plus 5 is 15. 7 plus 5 is 12, plus 3 is 15. The difference there is 0, so that is divisible by 11. Now you can see that's kind of a complex little rule to go through. And with calculators, you just punch in the number and divide by 11, and you're done. You don't have to worry about it.
That comma's throwing me up on the two.
What's that?
That comma behind the two is
Oh.
throwing me off.
Sorry, I don't know why I put that in there. There you go. No extra charge for the extra comma.
We should try to use that.
Go for it.
In the class for it. Can I get a point back on that quiz that I bombed?
You can try. So we mentioned that there's only certain numbers as we go larger that you need a rule for. There's other numbers you can divide by smaller things. This is what we call prime and composite numbers. The word composite means it's built of smaller components. You have composite materials, like you have Ceramat, which is metal and ceramic composite together, made up of two different types of material. Composite numbers means that they are made up of factors. So in other words, if they can be built by multiplying smaller numbers, they're a composite. They are made of smaller things. Prime means they have no factors. In other words, they can only be divided by 1 in themselves. They have no factors that can be used to build them. So like 7. 11 was prime. 13 would be prime. 6 and 9 would be composite because those can be made up of smaller numbers. You said you could divide by 2s and 3s to get 6 and divide by 3s to get 9. So just a little check here to see what you can... Is 14 prime or composite? That is composite. Is 2 prime or composite? That is prime. You want to think, well, it's even, but yeah, it's 2. You can divide by 2, but 2 is itself. How about 9? Composite. 11. Prime. 27. Composite. 35. Composite. 37. Prime. 41. Prime. 47. Prime. There's nothing that can divide into 47 other than itself and 1. 57. Composite. A lot of people want to say prime there because we just had, 47 and 37 are both prime, and 17 is prime. 57, though, what's 5 plus 7? 12. 12 can be divided by 3. So 3 times 19. How about 51? Composite. Still divisible by 3. 5 plus 1 makes 6. So if they're prime numbers, there's nothing we can do with them if we're asked to factor. If they're composite numbers, though, they have factors. So let's say we go back to our 24 and I ask you to factor that. Well, you could do factor pairs. So you could have 2 times 12 or 3 times 8 or 4 times 6. The question is, which one do I want? Well, we like for questions to be definitive in math. We'd mentioned earlier there's often more than one way to get to the answer, but there is only one right answer. So we want to make sure that we have questions in math that only have one correct answer. So rather than asking for factor pairs like this, generally what we ask is for people to prime factor. And prime factoring means break down every factor till it's all prime numbers. You can't break it down any further. So if I were going to prime factor 24, the easiest way to do it is to go back to the old factor tree. What is any number that can divide into 24? 2 goes into 24. So 24 divided by 2 leaves us with 12. You're correct. 2 is prime, so I'm going to circle it. That's just telling me I'm done. That's my end number there. Is 12 prime, or can it be split into smaller numbers? It can be split. What's one number that goes into 12? 2 goes into 12. 12 divided by 2 leaves me with 6. So 2 times 6 makes 12. Again, the 2 is prime, so I'm going to circle it. What are two numbers that can be multiplied to make 6? 3 times 2. Those are both prime, so I'm done. So I'm going to put them in order from smallest to largest. I have 1, 2, 3 2's. So 24 is 2 times 2 times 2. And then I have the 3, so times 3. So that is the prime factoring of 24. 2 times 2 times 2 times 3. You can, if you want to, shorten this up and write it as 2 to the 3rd power times 3. That's just a shorter way of saying there are 3 2's there. So let's look at 60. Prime factor 60 for me quick in your notes. So what's one number that goes into 60? 5? Okay, let's do 5. What's 60 divided by 5? 12. Is 5 prime? Yes, I'm going to circle. Is 12 prime? No. I can split it up into 2 times 6. 2 is prime, so I circle it. 6 splits into 2 times 3, or 3 times 2. So 60, smallest to largest, is 2 times 2 times 3 times 5. I usually leave it like that, but you could put it as 2 squared times 3 times 5. Any questions? So the question is, why do we care about factoring? Well, when we get into the next unit with fractions, there's a lot of things dealing with factoring that are very important to us. One thing is something called the greatest common factor. The greatest common factor is the largest number. When we're dealing with a pair of numbers, it's the largest number that will divide into both of them. So let's say I have 30 and 12, and I want to find the greatest common factor. Well, some of you can look at those and just know that largest common factor is 6, right? But what if you couldn't see that? Well, we could factor 30. 30 would be 10 times 3. 3 is prime. 10 is 2 times 5. Those are prime. So 30 is 2 times 3 times 5. Those are its factors. 12 would be 4 times 3. 3 is prime. 4 splits up into 2 times 2. So 12 is 2 times 2 times 3. The greatest common factor is built from all of the common factors. So what do these two have in common? They both have a 2 and they both have a 3. So what is 2 times 3? It is 6, which is what you had said was our greatest common factor before. So let's look at ones that aren't so easy. Let's do... You like easy? If you haven't learned yet, I always make it worse. It's kind of my thing. Oh, don't worry. We're not just out to get you. No, we're out to get everybody. Just kidding. We can't flunk all of you out because then we don't have a job anymore. So like 96, looks like 8 times 12 would work. 8's going to split into 2 times 4. 4 will split into 2 times 2. 12 will split into 4 times 3. 3's prime. 4 splits into 2 times 2. So for 96, I have 2 times 2 times 2 times 2 times 2 times 3. Got 5 2's in there. 72, let's do 8 times 9. 8 is 2 times 4. 4 is 2 times 2. 9 will be 3 times 3. So 72 is 2 times 2 times 2 times 3 times 3. So what do they have in common? They have a 2. Do they have another 2? Yep. Do they have another 2? Yep. Do they have another 2? No. But they do have a 3. 2 times 2 times 2 times 3 multiplies up to make 24. 24 is the greatest common factor for those two numbers. So in your notes, I want you to try one. Find the greatest common factor for 72 and 90. So when you factor 72, what do you come up with? Same as we got up above. Very good. 2 times 2 times 2 times 3 times 3. If you refactored it, great. If you caught that, recycling is always good, right? What do you get for 90? 2 times 3 times 3 times 5. So what do they have in common? 2, a 3, and another 3. 2 times 3 times 3 is 18 is the greatest common factor. Now the other side of it is something called a multiple. What a multiple is basically counting by a number. Let's say a multiple's of 4. That would be 4, counting up another 4 would be 8, 12, 16, 20, 24, and so on. Those are all the multiples of 4. They're called multiples because this would be 4 multiplied by 1, 4 multiplied by 2 is 8, 4 multiplied by 3 is 12, 4 multiplied by 4 is 16, 4 multiplied by 5 is 20, and so on. It's all the, if you start with 1 and work up one number at a time, it's what you'd get multiplying those numbers by 4. It's easier to just say counting up by 4s. But so those are the multiples of 4. So what we want to look at is something called the least common multiple. Now, unlike factors, factors are always smaller than the number, or equal to it at the very least. Multiples are always larger than the number, so we're looking at something larger than the numbers we are working with. So if I want to do a least common multiple of 12 and 18, I'm still going to factor them. Now we've factored both of these. 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. And just like with our greatest common factor, we start out by looking at what they have in common. They each have a 2 and they each have a 3 in common. But now for least common multiple, we focus on what they don't have in common. This has a 2, doesn't it? We don't have one down here, so we need it down here. So I'm going to put a 2 down there. This one has an extra 3, so I need to put an extra 3 up there. Now both of them have exactly the same factors, don't they? If I multiply them out, 2 times 2 times 3 is 12, times 3 is 36. 2 times 3 times 3 was 18, times 2 is 36. 36 is the least common multiple. So all I'm doing is taking all those factors and making sure they both have the same factor, filling in the missing factors. So let's look at something a little bit more complex, like, oh, I don't know, 72 and 90. Factoring 72 is still 2 times 2 times 2 times 3 times 3. 90 is still 2 times 3 times 3 times 5. You tell me where to start here for least common multiple. Well, I start by identifying what they have in common, first of all. They've got the 2's and they both have 2 3's. So you're right, the 72 has the 2 2's and the 90 does not. So we have to add 2 2's down here, or multiply by 2 2's. We have to bring the 5 up to the 72. 72 times 5 is 360. 90 times 2 times 2 is 360. 360 is the least common multiple. What do you think? Better than a sharp stick in the eye?
That's way too big of a number.
Way too big of a number? We won't hopefully deal with a lot of fractions that we end up having common denominators in the 360 range. That's getting up there. Okay. So homework on page 26. 1 through 63, the odd, deals with factoring. Factoring, divisibility, and stuff. Remember, tomorrow is our Unit 1 test.